Hello, I'm Drew McDaniel, and I'm a Principal Program Manager in the Microsoft Azure team. I've been with the Azure team for about 4 years as we've built out our virtual machine service, and today we're going to talk about deploying virtual machines in the cloud. This is actually part one of a two-part series that will go through how you use virtual machines in the cloud, and how virtual machines give you advantages that you may not have in other situations. In this talk, we're going to go through a brief platform overview. We're going to look at the components that make up the virtual machine, and then we are going to pull it all together through a set of demos and templates scenarios that allow you to put everything together to have a running service within Azure. Now, the Azure platform overall has been growing dramatically. The Azure platform is increasing the number of customers. We're looking at growing about 90,000 customers or more every single month. The Azure Active Directory, which we'll talk about in this presentation, which is the centerpiece for identity within the cloud, has over 500 million active users with over 18 billion authentications every single week through the Azure Active Directory. We also have the Azure Storage System that has over 50 trillion objects of storage with over 5 million requests per second on an ongoing basis of the Azure Storage System. Finally, within the virtual machines, we have the capability to deploy not only Windows virtual machines, as you would expect from Microsoft Cloud, but also Linux virtual machines and other open source operating systems. And in fact, 1 out of 4 machines deployed within Microsoft Azure today are Linux virtual machines. And then finally, as an example of one of the platforms and services that we have, is the SQL databases in Azure, and over 1.5 million databases currently active within Azure. And so Azure is just a system that has extremely large scalability, and we'll talk about how you can put that to your advantage through this presentation. Now, Azure itself is a worldwide platform that has data centers currently online in 22 separate regions around the globe. There's additionally 2 data centers that have been announced and will be brought online in the coming months in Toronto and Quebec City in Canada. So this scale and the network connecting the machines is what enables you to really put Microsoft Azure to use for you wherever you happen to be located. Now, each of those regions, each of those 22 regions themselves are very, very large. In fact, each of our data centers are built in such a way they're large enough to store 2 jumbo jets within that data center. Of course, we don't fill them with jumbo jets. We actually fill them with servers, but that's just the size of those data centers. We put those data centers together within the region to give you, in some places, up to 600,000 servers in some of those Azure regions. So it's just very, very large and immense scale and ongoing investment and ongoing build out across these regions and across these data centers. Now, when you're using Azure, you may be using Azure just directly within the cloud, but often you want to connect back to your location. So Azure allows you a set of options for connectivity to your on-premises machines. One is what we call point-to-site connectivity. This is what allows an SSL connection from any of your machines on premises or machines setting out an internet cafe to connect into the Azure Data Center network and have a direct connection into that system. For larger scale usage, you can build out a VPN that is a site-to-site based VPN that allows you to connect your entire location to Azure over the internet. And finally, as for customers that are using Azure in more heavy use scenarios, is what we call ExpressRoute. And ExpressRoute provides you the capability to connect Azure to your on-premise location using your telecom provider or using a Meet Me location like an Equinix location where your hardware is provided, your hardware is installed along with the communications equipment to give you extremely low latency, high bandwidth connectivity into Azure. And this allows you to use Azure for the places where it makes sense for your workloads, as well as keeping the data and configurations that make sense to stay on-premise for whatever reason to stay there, but the two interoperate very successfully. So we talked about the express route locations. As you'll see here in the slide that's building out, we have over 16 express route locations to connect up into our various Azure regions. Those express route locations not only connect you into Azure, but they also connect you to Office 365. In addition to Office 365, they also connect you into the Dynamics Online, the CRM solution. So the express route capability allows you to not only have very low latency, high bandwidth connection to Azure, but also the entire Microsoft Cloud. Finally, we have a set of CDN locations that are around the world. We have 31 CDN points of presence that allow you to get your content close to your customers so that your customers have the best experience when you are using Azure. Now within Azure, we're going to kind of walk through how everything is put together. So as I mentioned, there's 22 regions online that have the data center infrastructure. These are those data centers that have thousands and thousands of machines. Within that, we build out a set of infrastructure services. The core infrastructure services are compute, networking, and storage, which comprise the foundation of the remainder of Azure. This talk will cover into the infrastructure service and how we leverage those for virtual machines. But on top of that, and in other talks, you will hear how you can use the various platform services within Azure, whether that is compute platform services, cloud services, and Service Fabric, or data services and analytics. And so there's a broad range of services which you can use in Azure to either analyze your data, to store your data, and then pillaring that on both sides is security solutions and management, which we'll see a lot today within the portal and Azure Active Directory, as well as the hybrid solutions that I talked about, from the site-to-site connectivity to advanced things like Azure Site Recovery that allows you to use Azure as a disaster recovery region. And so this just gives you a broad view. We're going to now narrow in onto the infrastructure services for this talk. So the first part of virtual machine services is storage resources. Storage resources comprise blobs, tables, and queues. And we will use the blob functionality within the virtual machines to maintain the disks for each virtual machines. And we'll look at the differences between using standard storage and premium storage, which are the two options for the storage aspect of virtual machines. The compute resources comprise the virtual machine, the size of the virtual machine, the underlying operating system that you're using for the virtual machine, and then a set of extensions that extend the capability of that VM. Again, through the presentation, we'll dig into a little bit more of the extensions and the various virtual machine options that you do have. And finally, linking your virtual machines together, linking it to other resources, and linking it back to on-premises location is the virtual network. The virtual network comprises the configuration of the network, the subnets, the IP addresses, and a lot of security aspects of your network, so you can control which virtual machines can communicate which other virtual machines or on premises, such that you have full control of your system. So now let's look at storage itself. So storage is a set of disks that allow you to connect to Azure. Now, within a virtual machine, now we're looking at the individual virtual machine, you will see, if you just deploy a virtual machine, two drives. The C drive, which would be the OS disk that comes from your image, and then a temporary disk, which here is labeled as D. Now, these are backed by Azure Blob Storage. This is the Azure storage system. The C drive, as you can see, is backed by the Azure Blob system. The D drive is temporary. And so the D drive is a great solution for using page file. And in fact, we configure the page file for virtual machines on the D drive. But you want to be very, very careful not to store critical data on the D drive. Because if something happens to the virtual machine, if there's a power failure, hardware failure, that temporary disk, the contents of that, will be lost and be replaced with an empty disk. And so the temporary disk is great for scratch space, but is not something that should be used for critical customer data on the virtual machine. For critical customer data, we do recommend adding data disks. Each data disk can be up to 1 terabyte in size, and you can have up to 64 data disks on our largest virtual machines. These data disks are also backed by the same Azure storage, and it allows you to store databases and the critical customer data in a persistent location such that there would be no loss of data if there's a failure on the machine. Now, the individual persistent storage actually has 3 spindles in the back end. So when you write your data to the disks, it is replicated 3 times within that data center as it stores that. So you have very high reliability of that data. In addition, the data is replicated by default. This is controllable. You can configure it or to be on or off. But by default, it will replicate to another location that is at least 400 miles away from the primary location, such that you have the data stored very safely in the event of a disaster occurring within the primary data center. Now, we build out our locations within Azure in what we call geo pairs. As I mentioned, the data is replicated between locations. And so on this map, you see the data centers that we have. The matching colored dots are the dots that are geo pairs. And so as you see, the geo pairs are spread apart such that they're not in the same location geographically. There are 2 interesting data sites here, one in the southern part of the US that is both a secondary for north central US and a secondary for the location in South Brazil. And then finally, you see a similar situation in India where you have one location that is a secondary location for 2 of the other data centers within India. India data centers are just recently came online, and currently the India data centers are where Azure is the only public cloud that has operational data centers available within India. Now, continuing on this, not only can you use the persistent storage for your data disks, but you can also use Azure Files. Azure Files is an SMB file share for your data. And so in addition to your standard data disk, you can connect up other drives to Azure Files for persistent data. The Azure Files allows you to have shared access, and so it's a great solution for storing log files or data that needs to be spread across multiple machines. So again, any type of solution where you would typically use a file share, you can use Azure Files to connect to your virtual machines within Azure. Now, we talked about the standard storage. Now I want to spend a little bit of time talking about premium storage. Premium storage is the system that allows you to have much higher IOPS per virtual machine. So on a standard disk, you can have up to 500 IOPS, while on a premium storage disk, you can get up to 5,000 IOPS. So an order of magnitude increase in what you can do on the premium storage. In addition, you can store up to 64 terabytes of storage per VM, getting up to 80,000 IOPS per virtual machine. Again, that's the largest amount of IOPS that you're able to get within the public cloud for virtual machines. The premium storage uses a very unique solution where it uses the local SSD for providing a very, very efficient caching of read data, and then writing all writes and updates are then pushed to persistent storage. And so you really get the best of both worlds. You get a highly efficient cache, as well as all data and all writes going to back-end storage, so it's highly reliable, stored across those 3 data disks as we were looking at before. So here we show with premium storage, there is that disk cache. That disk cache is backed by an SSD-based disk that allows you to have very, very high performance of your premium storage when going through and using your Azure virtual machines. So with that, we're going to look at a quick demo of premium storage. So what we have here is the Azure portal. First, let me show you. If you just start up, you will actually see the current Azure portal. This portal is the current general availability portal, but we also have the preview portal, as labeled up here, is preview. And this portal allows you to have a very, very more DevOps-centric environment. It is customizable. For example, I can come in here and I can change where the items are stored, what I want to see here, and it's very, very flexible, so you can configure it as you want. So for this demo, I've actually set up a machine. And so this is our disks machine. And if we come into the virtual machine, we have a set of properties. And we can come down here and look at the disks. And we'll see that we have the operating system disk, and then we have a single data disk of 200 gigabytes that is standard storage, and then a second disk that is of premium storage. So what this looks like on the virtual machine, go ahead and connect into this. So here we see, as we talked about in the demo, the C drive is your image, the OS disk itself. Temporary storage is D, and you see that we've got the page file here on D. And then the two disks that we just saw in the portal, the standard disk that is the 200 gig disk and the premium disk. Now what we're going to do is to use a tool called Iometer to actually show the performance of the disks. So we're going to come in here and we're going to start up Iometer. And what this does is gives us a, we're first hitting the standard disk against a access specification of 8K I/O. And we're going to kick this off and we'll just show you what this is going to look like. So here we see within the total I/Os per second, we see 490 I/O operations per second. This is the standard disk, well, it should top out at about 500. And also notice that the average response time is about 32 milliseconds. And this is pretty typical in what we expect to see in standard storage. Now we're going to close this and move over to premium storage. So here we're going to run that same test, but we're running against the premium storage disk. And we're going to see that now we're actually looking at, here we're looking at over 5,000 I/O operations per second. And if you look down here at our average response time, we've went from around 30 milliseconds now to about 3 milliseconds for the response time. So this just goes to show the power that you have within the Azure Premium Storage. Now, one other thing we'll show real quick here is another machine. This is a bigger virtual machine. This is what we call our G-Series virtual machine. On this, I've configured 20 premium storage disks into one volume using storage spaces. And we're going to run that same test now on a premium storage disk. This is now backing 20 disks with premium storage. And so running that same test, now we're going to see that the premium storage is now on the order of, here we're seeing over 80,000 I/O operations per second coming out of premium storage. We're seeing that using the local SSD for the read operations, we're now seeing an average response time of about 1 millisecond. And so this allows you to run the largest of workloads within Azure Virtual Machines using premium storage. With that, we're going to return to the deck and take the next look at the next component of virtual machines. So we've talked about the storage aspect. Now let's look at the compute. We talked a little bit about the size, and we'll dig into the difference that we have here. So from the options that we have within compute, we have the A series of virtual machines, which gives you the highest value. The D series of virtual machines, which gives you the kind of the best balanced performance using local SSD, faster CPUs. And then what we saw just a moment ago is the G series of virtual machines that really is the most memory, the fastest CPUs available within Azure. And actually, currently, those are the largest virtual machines available within public cloud. So the A series of machines, the A series is a great solution for standard workloads where you do not need a large amount of CPU, you do not need the local SSD. You have the capability to run basic and standard. Basic allows you to run the A series of machine without using a load balancer. It lowers the price a bit. And it's really kind of a general purpose workload. In addition, there's a set of A series machines, A8 and A9, that bring in the high performance, low latency network, remote direct memory access, where you can do high performance workloads, getting connectivity between the machines down into the tens of microseconds range that allows for various applications that are just not possible on typical hardware. The D series of machines is about 60% faster from the A series, newer CPUs, larger amounts of memory. You can run up to 112 gigabytes of memory. They have the local SSD that enables you to use it for your own workloads or for caching, and the D series machines is now available in all of the Azure regions. Finally, we have the G series. The G series is what we looked at there at the end of the disk demo, and it's optimized for these data workloads. You can use up to 32 CPU cores of Haswell-based Intel processors, almost a half terabyte of RAM on the machine, and over 6 terabytes of local SSD on the machine to be used for your workload. The G series is also the series that allows you to attach up to 64 individual disks, giving you that total storage capacity of 64 terabytes. Now we're going to talk a little bit about how you configure your virtual machines for high availability. Most of the time you have a workload that you want to have redundancy and high availability. The way that you do that within Azure is what we call the availability set. The availability set tells Azure that these two virtual machines are performing a similar function. In this case, in the example, we have a SQL server who's primary and secondary. But by telling the platform that these machines are in an availability set, we can make special use of that information to increase your availability. So what we have here is a picture of a rack within the Azure data centers. And what you'll see here is a set of machines, the physical machines, that are in the rack, as well as there in the middle, we've got a power distribution unit. And so within Azure, that single power distribution unit, or those individual machines, is a single point of failure. So if you're deploying a high availability workload, you want to have your workload spread across machines. So what we see here in the data center, as we have these machines spread out, when you deploy a machine using an availability set, we will automatically spread that across those machines within the Azure data center so that you do not have a single point of failure. And this is how the availability set increases your overall availability of the virtual machines. In addition to spreading it across hardware, we will also spread it, make sure to not update the individual instances that are deployed at the same time so that we don't take down your application. This way, if you have a hardware failure for some reason, or that a rack were to have a power distribution unit failure, the machine is stored, and the rack would be repaired, or the virtual machine would be moved to another rack for what we call service healing. Now, finally, we want to look about networking. Networking is the final piece of the Azure virtual machine platform. So first, with networking, one of the common things you'll see is load balancing. And so we have the capability to do both what we call internal and external load balancing. External load balancing is load balancing for data coming in from the public internet. Internal load balancing is load balancing data from within your network. The payload will come through. Here we're showing it hitting port 80, so a typical HTTP request. And the load balancer spreads that across the virtual machines that have been configured to take that call. We use a 5-tuple to associate the caller to the individual virtual machines. So as those sessions are started, it will stay on the same virtual machine. Furthermore, you can use ACLs to control which IP addresses from the external network, or IP address ranges, can connect into your virtual machines. This is often used if you have a solution that is only used as like a backend for your workload. You may ACL that down so that only your administrators and the front-end network can connect into that so that you have higher security. And finally, you have the capability to use a custom HTTP probe so that if a machine is coming up and is not ready to service responses, the custom probe will check that machine to see if the machine is ready. And if the machine is not responding with a 200 and saying it's ready to receive traffic, then the load balancer will automatically send traffic to other virtual machines. Now, as I mentioned, the internal and external network, we're actually going to show, here's a connection coming through from the internet into your virtual machine. So here, whether you're on premises or from somebody out in maybe a a coffee shop connecting over the internet, they can connect into that public IP address that gets load balanced onto the virtual machines. However, if the application is primarily being used from an on-premise location, you can configure this using an internal IP address. This internal IP address is available over the SSL point-to-site connectivity and site-to-site connectivity that we mentioned earlier that allows you to only allow connections in from those secured locations such that you're not exposing your workload to the public internet, but connecting over the various hybrid options that we have available. In addition, you can use the internal IP address to control load balancing to the back-end network. And so again, here we're showing the example of using a front-end network, connecting into the back-end network using an internal IP address. And these would all be configured within an Azure Virtual Network. Now we can see how that functionality of load balancing can then be used for increasing the high availability. So now we would set up a load balancer directing traffic to those virtual machines. And if that same situation happens as we actually have a failure within the rack, then the load balancer will automatically detect that, see that the machine is no longer responding to pings, and send all traffic to the VM1 as we see on the screen. The platform would then automatically heal the VM2 to another location, and then when it comes back up and starts responding to those probes, then traffic would go to VM2. And this is how the use of availability sets and load balancing allows you to have a very high reliability and highly available application within Azure. So now we want to look at how this all comes together with the various applications within Azure. So the Azure Marketplace is the one-stop shop for a wide variety of solutions that are available within Azure. These solutions are both Microsoft solutions as well as solutions provided by our partners to give you a first-class experience within Azure. In fact, the Azure Marketplace started off with just a handful of machines or of applications from third parties. As of the time the Marketplace launched in late 2014, we had over 50 individual applications from partners in the Marketplace. And currently, we have over 300 different applications available through the Marketplace that continues to grow and grow. And these are partners working with Microsoft to provide their solutions in Azure in a very first-class way, tested, validated, and providing examples on how to run those applications within Azure. In addition, we continue that into the open source space. So this is just a look at some of the open source solutions that are available within Azure. From clients, whether that's working with Android or iOS mobile devices, management, Chef, Puppet, Docker, a set of solutions that are available from open source providers, as well as applications and frameworks and database and infrastructure. And as you can see here, that Microsoft Azure stack goes much, much deeper than just a Microsoft solution. It's a solution for partners that provide end-to-end solutions for our shared customers. Now, next we want to talk about the VM extensions. The VM extensions is what I've mentioned before, allows you to extend the capability of a virtual machine. It enables you to have easier management, a larger partner ecosystem, but at the same time, the VM still remains within your control, so you can configure it as you want. The way the VM extensions work is when you go through the Azure portal, you have a selection of extensions that you can apply to the virtual machine. When you select to apply an extension, here we've actually selected to apply the Symantec and PowerShell extensions. Those will be brought into your virtual machine from the curated repository that is available in Azure and then run on the machine. And we'll show here in just a moment how you can actually use this within Azure from the portal to extend the power of your virtual machine. What we have, the building blocks within the virtual machine, is the operating system disks and the extensions. On the operating system disk, we have a large variety of Windows-based operating systems, as well as Linux operating system from Ubuntu, Oracle Linux, SUSE, CentOS, and just a wide range of Linux operating system available for you to run out of the gallery or to bring your own. Then, as part of the marketplace, we have a set of certified images that are available. These are both from first parties, as we're showing here, for example, Dynamics, as well as third parties like Oracle WebLogic or the Java JDK that are available for you to quickly use in Azure. Finally, there's a set of community images that are provided across a wide range of options that, again, you can use within the virtual machine. So that's your base operating system. Onto that, we add the extensions that extend that base operating system. So some of the extensions we have are security-based extensions, deployment and management solutions. So whether it's Visual Studio, Chef, Puppet, Octopus Deploy, or configuration tools, whether that's the PowerShell or the ability to run a custom script, you have a large variety of options to extend the virtual machines through those extensions. And in fact, others that are used here, extensions are used for diagnostics, monitoring, access recovery, Docker extensions to use containers within the virtual machine, as well as backup helpers that allow you to have a very efficient backup solution provided by Microsoft and third parties. So let's look a little bit at what that looks like within the Azure portal. So we're going to come back to the Azure portal, and I've got a machine set up for showing you some of the various extensions. Again, we've got just the virtual machine. This is a Windows virtual machine that was deployed. And in the same configuration here, we have a set of extensions. So if we click on the extensions, and then we click on Add, we're able to see a set of these extensions that are available for you to install within the virtual machine. From the configuration, from the security-based solutions, down to even transparent encryption of the virtual machine. We're going to select the Microsoft anti-malware. So what this allows you to do is configure each virtual machine to have anti-malware installed automatically. We're going to click Create. It allows us to configure excluded locations, file extensions, configure as we want, or set a scheduled scan. We're going to set up a quick scan to run every Saturday, just taking the default. And now if I click OK for that configuration, the system is now applying that extension to the virtual machine. It's pulling the anti-malware package down from the curated location, installing that to the virtual machine, and then it will continue to keep that updated on that virtual machine. So if there's an update to the anti-malware package, the Azure agent will reach out and grab the current version and keep that machine always secure. And so this is just a way that the extensions allow you to have higher security, more functionality within Azure than you'd get in other locations. All right, with that, we're going to return back to the deck. Now we want to talk a little bit about the different variations of the Azure Virtual Machine. We have what we call the Classic Virtual Machine that was available when Azure launched. The Classic Virtual Machine configured a cloud service, storage account for storage, and a virtual network for the disks. What it would allow you to do, set up your virtual machine with an IP address that was then connected and using the disk and blob and the subnet in the virtual network for your machine. And then finally, you can configure that with a load-balanced endpoint and use ACLs against the load-balanced endpoint to get security within that. In addition, we've just recently introduced the Azure Resource Manager. These are our second generation of virtual machines, or V2 virtual machines. And we've taken the original configuration of just the cloud service, storage, and network, and provided more flexibility in configuring. Here you can see the network interface card, the NIC, as well as load balancer and IP addresses as individual items that can be configured. And each of these then have dependencies within this, such that the set of machines can be automatically deployed through this resource group manager in a very orchestrated manner. Finally, you also have the network security groups, which can be applied to the NIC for security or to the subnet to have security within that virtual network. And this allows for a higher degree of configuration In addition, it allows for an orchestrated deployment of multiple machines, which we'll see a little bit later in a demo. So if you want to have an orchestrated deployment of resources through the Resource Manager, here we're showing an example of a template, a SQL Azure website. Now this website uses a SQL Azure database. This is a Platform as a Service database that connects into a Azure website and then uses a set of virtual machines. Now you configure a template that defines the entire set of dependencies within the machine, and then the system will deploy that. It ensures that everything is deployed in an idempotent way. You can roll back as you want, but more than anything, it allows you to store your configuration as code. You can check in the template that you've actually deployed into Azure and rerun that as you want in the future by just changing the set of parameters that are input into that template. Now let's go in and look a little bit on one of these templates. So first we're going to come back to start a new deployment. We're going to look at compute, and we're going to first drill into the marketplace. Now the marketplace is the location that shows all of the different options available within Azure. So here's a set of images that are recommended from Windows Server, Ubuntu, Hortonworks, MapR, a set of certified images so that we have in here. And if you click into more, you would see a large set of certified images that are available in the platform. And this will continue to grow. As I mentioned, there's over 300 certified images available in the platform currently. And so from the marketplace, you can get to a wide variety of different solutions. For this, we actually want to look at one of the template-based solutions. Actually, we're going to bring up SharePoint. So I'm going to bring up the SharePoint configuration. And here we have two versions, an HA and a non-HA configuration. We're going to use the non-HA configuration just because I have a certain amount of quota in my subscription to use. As you see here, this is only available for Resource Manager. That's because this template is going to deploy multiple virtual machines. And the Resource Manager is required to orchestrate that deployment. Now, what we'll have here is that a set of questions that have been provided by the publisher, in this case SharePoint, that is very specific to the application. So here we see the SharePoint farm name. We specify a resource group. So this is the resource group stored within the subscription. So demo SharePoint. The resource group makes it very easy to have security applied to all the resources in there, or to apply tagging that will show up in the bill to allow for easy chargeback. And then you select the location you want to deploy this to. We'll, in this case, select our US West location. Now we have the various configuration for SharePoint. So here we're taking the username. I'll just use my own username and a password. And we go through and set the various password configuration. Now here we have our storage account. As we mentioned, within storage in Azure, you have the capability to use either standard or premium. We're going to create a new storage account. We'll call this demo SharePoint MVA. And we can configure this as if we want it to be premium, locally redundant standard, or geo-redundant standard. We'll take the geo-redundant standard in this case. I'll put my alias in here so we actually get a name that's usable. And we'll enable the diagnostics. See if that validates for us. Okay. So now we've set the storage type, the virtual network where this will be deployed. Now we configure the Active Directory. So we can configure the domain name that we want. We're going to configure, in this template, it's going to deploy domain controllers, SharePoint server, and SQL database. So here we use the recommended standard DS machine. Within Azure, you have the capability of, as I mentioned, a set of sizes. Here, the recommendation is the DS2. If you do not want to use premium storage, you can use just a D2. The S signifies that the machine is capable of the premium storage utilization. So we're going to go ahead and use the S virtual machine. We're going to configure SQL Server. Again, we're going to set the passwords for the system. Now we've configured SQL. Now we again configure SharePoint. So here we're setting up the public IP address. This will be the address that will be visible publicly. So we'll say this demo SharePoint machine size. And again, for SharePoint, we have a set of passwords that we need to enter here. The farm account password, which is part of SharePoint. And then the farm passphrase, which is another thing you need to set up with SharePoint for doing administration and configuration. And then you have the option to configure whether you want team site, just a blank site, a doc workspace. Now, the great thing here is this was all done using data-driven UI. There's nothing, we didn't build a UI that was specifically for SharePoint. It was all configured as part of the publisher. And in fact, if you go through and use some of the other templates, you'll see a completely different UI flow. You can then download the template that the system's going to execute. I'm not going to download it right now. We'll just click OK. It's going to ask for show the legal information about what you're purchasing, and if what you're purchasing is going to charge extra. We're going to click Buy here. And now we can go through and get that launching. And so now that is deploying. It's going to take a while to deploy the individual machines. And again, it's going to start with the Active Directory machine, then deploy SQL, then deploy SharePoint. What you end up with is a resource group that has the 3 machines. So this is the non-HD, highly available one. So we've got a Active Directory, SQL, and SharePoint server. We've got the load balancers and availability set that allows us to grow that machine as we want. If we look at the deployment information, here we'll see, if we pick the top item here, we will see the fully qualified domain name to the SharePoint farm, and then all of the configuration that we had set, except for the passwords. The passwords are not shown here. Those you need to remember because we don't want to expose any passwords. And so you have all the configuration, and what you end up with is a SharePoint farm that looks like this. Here's the configuration. It's all was configured and ready to go. It's been configured in an optimal way using the best practices recommendation from Microsoft and the SharePoint team. So we're going to move back to the slides for a wrap up here. So in closing, what we enable within Azure is hybrid, enterprise grade, and hyperscale. We bring all of the pieces that you need to run your application, whether that's in Azure or on premises, using the capabilities and having the backing data center at hyperscale behind you. You can bring the cloud to you, use it as you need, configure either infrastructure services or the upper layer PaaS services to deploy your application in the cloud or on premises as you desire. The Azure system will allow both agility and time to market while lowering your overall TCO because you pay only for what you need with per minute billing and the virtual machine sizes. You can configure it to fit your application as you need at that point in time to dramatically reduce your overall total cost of ownership. Finally, you have the Azure platform behind you to scale at any time, whether that is scaling to larger machine sizes, scaling to more machines, or scaling across the world. Azure allows you to complete your service and meet your needs as you need. Thank you.